Alright, so we've already done problems like 1, 2, and 3. All of these are in exponential form. And when we did 1, 2, and 3, every time you were given the time. And you didn't have to solve for it. If we have to solve for time, time is an exponent. And when we solve for an exponent, we use a logarithm. That's right. Now, so this is our review part there. So if we started with 100 fruit flies and the population doubles each week, how many fruit flies will there be at the end of 6 weeks? So our initial amount is A in this case, which is 100. The population doubles every week. So when we have words like double or triple or quadruple, it's just the number. The only time we add or subtract to 1 is if it's a percent increase or a percent decrease. But this is double, so it's a plain old 2. Now, every word problem will define your unit of time. And this time, it is defined in weeks. So how many fruit flies will there be in 6 weeks? Well, we don't have to change much because our unit of time was weeks and they gave us weeks. So we have 100 fruit flies as our initial amount. We are doubling every week for 6 weeks. How many fruit flies do we now have?
6,000.
That's right. 6,400 fruit flies. All right, so now these math problems are in context. So when we have something in context, we need to define what the number means. So you're going to give some type of unit, and in this case, it is fruit flies. Okay, number 2. The population of a school is currently 1,550. Is that greater or less than Starsmill High School?
Greater. About like 200.
Greater.
It's greater about like 200. It has to be greater.
It is greater. We're right around 1,400 right now.
That's close.
Yeah. We are a small 5A school. So, all right. So we had the initial amount was 1,550. Unfortunately, this school is in a population that is decreasing by 8% each year. And if you study other classes, you can talk about why that would occur. But in here, we'll just do the math. So how many students will there be in 10 years, assuming this decrease continues? You would hope not, because this is going to be ugly. I like to call it population with respect to time. So the initial population is 1,550 students. This population is decreasing, and 8% is pretty rapid. And how many students will be left in 10 years? So it was 8% each year for 10 years is 10 time periods. So that's what we punch in, 1,550, 0.92 to the 10.
600.
All right. I've probably lost my job at this point because we're down to 674 students. Okay, why did I round up?
Because when you're going down, you have to round up.
That's right. If it's decay, we round up.
When you're increasing, you round
If it's growth, we round down. Anytime we have a discrete unit, which we do. It's people. All right, so after 10 years, we are hurting. We might be single A classification by then.
I have like 2 teachers.
All right, actually that's still bigger than the high school I graduated from.
Are you serious? Where'd you graduate from?
Pike County, but I graduated from Pike County in 1990. So that was many a year ago, but there were 396 students.
396.
396. That's like one class. No, that was a whole school. Yeah.
It's like
So. All right, and that is why it was easy to make any team you went out for. You showed up. If you fit into one of the uniforms they already had, you made the team. That's pretty much it. It's awesome. All right.
How much does school have? Like 100?
Number 3. John Invest 2,500 at 5% interest. Nice rate. Compounded quarterly. Compounded our compound interest formula. How much will John have after 10 years? Now, when we talk about all these compound interest, we're talking about putting money into an account and completely leaving it alone. Not adding to it, not adding and taking away, which is what most people do. Now, with, say, retirement investments, generally you just add to them. Seldom do you take away because the tax consequences are generally painful. So, in this case, the amount with respect to time is going to be the initial amount, which is at 2,500, 1 plus the percentage written as a decimal over 4. Why is it 4? Because it is quarterly. And 4 times t, which is 10. Okay, so we are compounding this money 40 times. 4 times a year for 10 years. So we'll type in 2,500, 1 plus 0.05, divide by 4, raised to the 40th. John does well. After 10 years of leaving this money completely alone, John would have $4,109.05.
Yeah, I thought it was going to be much more than that.
Yes, sir. 40 times gave
Yeah.
Normal interest rates like really low, right? Like 1%.
It's like 0.02.
It's like
Right now,
I get like
terribly
I
low.
get
It's like
2
1%.
cents a month.
It depends on where you are. I just got my bank statement for how much my savings account earned last year, and it was $12 for the year.
Making bank.
For the year.
So that's 12%.
That was my savings account.
It's like
Now we have lots of accounts,
Yeah,
but
but still.
that one earned $12.
Like I said,
Like,
percent
I
on
got
the
my
I think I found more money than that on the ground last year.
I got my bank statement and it was 2 cents a month.
Yeah.
And I was like, this is why even do it? Like, why even write it?
Okay, first of all, you're training yourself.
Well,
Second,
yeah.
that's not the type of investment you make when you want to watch your money grow.
Yeah.
I'm just going to hide this money away so it doesn't disappear. When you want your money to grow, you would invest it carefully.
It's a difference. You invest in opposite stocks. You want to go
And if
from
I had
like
money, I'd buy
you
it.
buy go into
Alright.
tech and it goes like something completely different, like painting.
Alright, number 1.
Is this the new stuff?
This is the new stuff. So, yeah, we are.
Oh,
It's going to be a
wow.
great recording.
I'm so sorry.
Just don't say your name.
Alright, so, now we're going to look at using logarithms to solve for the exponent. So anytime we have an exponential situation and we're solving for the time, because the time is our exponent, then we're going to use logarithms. This really does have a lot of application. Anybody in AP Chem? Not in this class. Okay, they've been using it in there too. So, alright. So, in this one, you start with 25 fruit flies. They're still doubling those stinking fruit flies every week. How long will it take for there to be 880? So we know what we want it to result in, 880. But we don't know the time. So we're solving for X or T or whatever you denote it as. So we're going to divide by 25. Why am I dividing by 25 first? Because to use a logarithm, I have to be in exponential form. I have to have a base raised to an exponent equal to an answer to be able to take the log of both sides. This problem had extra stuff. This was my base, and this was my exponent, and this is a initial amount that I need to get rid of. So the way you would get rid of multiplying by 25 is dividing by 25. So 880 divided by 25. Ooh, that divides nicely. I get a nice number like 35.2. Now, if I were to not get a nice number, if my number was like 35.214378295, okay, you would leave it as a fraction and let your calculator deal with it later on. You don't even have to worry about it. This would be on the calculator section of a test, right, Abby?
Yep.
Okay, so So, now we're solving for the time. We're solving for the exponent. So now what do I need to do?
Log based.
That's right. We're going to take the log. And so when I do, that x can come out in front. So what I have is log of 35.2. I pushed that in the wrong order. 35.2 is equal to x times log of 2. Now how do I solve for x?
Divide by log of 2.
Divide by log of 2. That's all that's left.
For these, we'd want to put the approximate, right?
Yes, you would. Because at this point we are approximating. We are rounding. We would say it would be about 5.173 weeks. So during the 5th week.
Wait, I got a 5.1375.
Oh, that's because you're correct. My brain flipped the numbers.
Good job, Goody.
Yeah, my calculator did good job.
He's a smart calculator.
Alright,
Do some drugs.
so do you see that these are not much different than the problems we've been doing? There's just a new step 1. You got to come up with the problem. And then you solve it.
Watch the good.
Okay? So number 2. The population of a town is 12,500. That's a little town. If the town is growing at a rate of 3% per year, how long will it take for the town to reach 1,800 people? All right, so our initial amount is 12,500. But we're growing. 3% is actually a pretty rapid growth rate for a city.
I wonder what the growth rate of Peachtree City is.
I think it's in decline. Yeah, I thought it was in decline.
I don't know. That would be some good data we could analyze.
The return rate is
How do we do
awful.
that?
So,
No one comes back once they visit.
No, Fayetteville has the worst return rate of all of this country.
What do you return?
Like of college kids that go to college and never, like families that like leave and never come back. Like
Ah.
college kids.
Oh.
interesting.
Fayetteville, Georgia.
All right. So what do we do?
Divide by 12,500.
Yes, you do. Once you get it here, they all work the same. It's just coming up with the equation. Don't give it extra zeros either. That's always bad.
Zero.
Okay, so if I take 18,000 and divide by 12,500, I get 1.44. That's not bad. You can write 1.44. 1.03 to the T. All right. What do we do at this point?
Log.
Take the log of both sides.
Log that again.
So this becomes log of 1.44 equals T times log of 1.03. So to solve for the time, I would just merely divide. Log of 1.44 divided by log of 1.03 is equal to the time. Yes?
So say you change your variable equation, like instead of 50 you would add 12 in the end.
So how about if we use the
Does that
fraction?
like interfere with like the
No.
No, we don't have to use fraction.
So we would reach that 18,000 if we continue to grow at this rate per year and during the 12th year. So you could write 12.336. Time is a measurable quantity, So it's okay to have decimals.
I mean,
It's not a discrete.
like in the 18,000 divided by 1,000, 2,000, 12,500.
Yes.
Can we use fractions?
You can leave it as fraction. Sure.
Can you do the fraction one to me? Like how?
You want me to show you the fraction?
Yeah.
Sure.
I did is like 36 over 25, and how we do next?
Yeah, that's fine. So what you would do right here, if you left this as a reduced fraction, let me erase this quickly and I can show you guys. You just have to make sure you put your parentheses in the right place, Gooey. So you would do 36 divided by 25.
Oh.
Close that parentheses.
Oh, okay.
And you'll be all right.
Okay.
Sure. Yeah. This isn't, well, look at there. There's the answer to the last one. Okay. So John, he's going to invest $500 at 3.5% interest, compounded monthly. John found a good deal. Yeah, for that small amount of money. Actually, 500 is a lot of money to me, but when you're talking about investing in rates.
Yeah, interest. That's
Uh-huh. How long will it take John to have $3,000 in his account?
like half.
Okay, that's going to take a long time because that's 6 times its current value. And though 3.5% is a good rate for what we have going right now, it's not like phenomenal.
Call it
So,
27 years.
do you think you can do it?
27, that's the number.
Lucky number 13.
All right, at least, yes, you try. You at least try setting it up.
I will try. That's number 13.
Okay.
That's about the right number.
Okay, so when we write the x for the time, or we write 12 since it's compounding monthly?
It's going to be 12 and x, okay, or 12 and t. So our ending amount is 3,000. Our beginning amount is 500. It's 1 plus the rate written as a decimal. So we had to convert that percentage to a decimal, move it twice. Monthly means we're dividing by 12. So what happens up here is we have 12 times t. 12 times t. Okay? So when we go to solve this problem, the first thing we'll do is divide by that 500, which I told you it was 6 times the original amount. So what does it turn into over here? 6. Oh, if we divide this out, it gets ugly. So since it gets ugly, it's not a pretty decimal. We're just going to leave it like that.
Yeah.
Yeah?
If we round it, like I rounded it to 1.003.
You will get close. You'll get close. And generally when we do one calculation, rounding doesn't have a tremendous effect. But if we round something and then we use that data, the answer we get again, we're going to compound that rounding error. So your error gets bigger and bigger and bigger the more times you have to use that answer. So I try to be exact as long as I can. Alright, so at this point, we're going to have to take the log of both sides because we need to solve for that variable, which is up here as the exponent. It pulls it out in front. So we get log of 6 equals 12t times log of this craziness.
I was 2 years off Gooey's answer.
Alright, So we have to divide by the craziness.
Yes.
And you should get this.
Yay.
Yeah.
Yay.
Now,
So can you
at this point, I have not solved for time. I've solved for 12 times the time. So what do I have to do? Divide by 12. So when we divide both sides by 12, you get approximately 51.268 years. So, you guys would probably see that happen. If I were John, it would be a little iffy because I'm currently
51
40.
years.
I'm close enough to 46.
I can buy a
Plus 51.
maybe.
I'd be old.
Yeah.
I'd be old.
You're like 30.
I know.
What are you gonna buy with that money, Green?
What?
The whole $3,000.
Yeah.
Okay. Now, the last thing I want to talk about is
Yeah.
Richter scale applications. I actually have this cool little video about Haiti. Do y'all remember Haiti had a
Oh, yeah,
fairly
Haiti.
severe
Yeah.
earthquake about 7 years ago?
Yeah.
It was massive damage to Port-au-Prince.
Yep.
So I have a little video to show you about, and does a good job visualizing the intensity of the earthquake as it changes. Like when we think of the difference between the number 2 and the number 7, that doesn't seem like a big deal. Between 2 and 7, that's only 5. But a Richter scale is a logarithmic scale. That means 2 is an exponent. 7 is an exponent. Okay?
What is it?
So when we think about the difference, and it has a really good visual in there. So I'm going to show you that on Wednesday.
Oh, darn. Let's watch
Yeah.
it now.
Everyone showed
You want to watch it now?
Yeah.
Yes.
All right. Well, we'll save these problems and we'll watch the video now.
Sweet.
Save
Save them
All right.
for
So on the back, stop. You're really just doing 1 through 4
Oh yeah.
because I don't have a chance to talk about 5, 6, 7.
Oh yeah. That's a great idea.